Alright, in this video, I'm going to talk about binomial expansions for the case where the n is a rational number, right? As you know that a positive integer is the subset of the rational number, a rational number, right? A rational number. So rational number means a number that can be written in the form of a over b, where a and b are the integers, right? In the fraction, alright, is in a fraction. So now, means that all that you learned previously during the for the binomial expansion, Pascal triangle, all that is for positive integer. Means that the power of the bracket is 2, can be 3, can be 4, 5, 6, 7, 8, right? So when you have positive integer means 1, 2, 3, 4, 5, 6, 7, 8, so and so on and so far. So for all this type of expansion, you can terminate. The term can be terminating. Means that if you expand up to, for example, 4, if you have power of 4, you will expand plus. You will have, if you expand power of 4, you will have fifth term, right? They will full stop somewhere. Means they will expand, they will end. The series will end somewhere. Dia akan berhenti pada satu masa. So, but this case, binomial expansion, when the n is a rational number, means that rational number is more than that. Means it can be the power here can be 1 over 4, can be negative 2, can be any number that in the form of, can be written in the form of fraction. Alright? This formula is more powerful, alright, or is more powerful in expanding the, using to expand the series, okay, a binomial term, alright. So if this case happen, so you have to learn how to expand using this formula, alright, this type of formula. So where the integers is subset of this, means that this method is more general, means that you can use even for expand the positive integer. Alright, so let's see how to expand square root of 1 minus 3x. So square root of 1 minus 3x, in your life you maybe never know that, wow, you can expand something with power 1 over 2, right? So if you have 1 minus 3x power of 2, you know that you have 2 bracket, right? Clearly, if you have power of 2, you have 2 bracket. This is always valid, right? This is always valid. So because you know that power of 2 is going to be this 2 bracket, alright? You multiply, you expand. So this is valid, right? This is valid. But for this type of expansion that you have square root 1 over 2, how to separuh? Separuh, okay. Separuh, okay? No such meaning, right? They are meaningless, yes or not? So you cannot expand 1 minus 3x to the power of half. But due to mathematics is very advanced, right? So you will learn why this can be expanded, okay? So there are conditions. So means this type of expansion, we have a condition. Later I will explain to you. So, okay, let's look at the pattern, okay? The pattern. So instead of applying formula, I want you to see in this video how to expand by using a pattern here. So first, the condition here must be 1. Must 1, okay? This case is already 1, is okay. So the pattern will be this way. Now it's starting very important. So you write 1. Every time start with 1 for the first term. And you add plus. The second term is the one that you must correct, alright? Because after this, all you were using the second term. So you take the 1 over 2, the power, multiply with the negative 3x here. Always take the n, multiply with the b, alright? N multiply with the b. So this is very important. I tell you, you take the power, multiply with the b, negative 3x. So okay, after that, the third term will be this way. Copy this thing, you write in the form of fraction, the 1 over 2, and the negative 3x you copy back, But from 1, this one become power of 2. Alright, become power of 2. So the 1 over 2, you will add another bracket which you take 1 over 2 minus 1. Alright, minus 1. So if 2, here you have 2 factorial. Alright, if you can't see the pattern, I write for you. I write for you for many times so that you can see. So now we go for the third term. This is your first term, second term, third term. So you expand. So you will be writing back 1 over 2, copy. For this, you copy back this, right? Now for this fourth term, you copy back this. 1 over 2 minus 1. This one I copy back. So I draw this. So for this one, negative 3x. From 1, it become 2. This one become 3. Alright? And for this case, look at this one. If 3, here you will have 3 factorial. Alright? 3 factorial. But for this, you add another bracket. But now you take the 1 over 2 minus with 2. Minus with 2. Okay. Sir, I still can't see. Never mind. Come, let's enjoy. You can see again. So now you want to get for the 1, 2, 3, 4, the fifth term. So the expansion, copy back. This one. So 1 over 2, 1 over 2 minus 1, 1 over 2 minus 2. Okay, there is a bracket here. Another bracket. But now I count this one first. Negative 3x. Now from 3 become 4. And because of 4 here, you divide by 4 factorial. You try to guess what is the value that I'm going to put. You see that minus 1, minus 1, minus 2. So minus 1, minus 2. This one will become, of course, will be minus 3. Right? Okay, still cannot understand. Doesn't matter. Okay. So let's see again. Copy back this. You expand. It won't finish. 1 over 2. 1 over 2 minus 1. 1 over 2 minus 2. 1 over 2 minus 3. Add another bracket. So now the negative 3x will become power of 5. Divide by 5 factorial. And this one, you try to guess, it will be 1 or 2. Minus 1, minus 2, minus 3. This one will be minus 4. So I hope you already understand. Alright, if you keep adding, it won't finish. It won't finish, not terminate. It will not terminate. Except if this is an integer, power of 1, power of 2, power of 3, power of 4. So this is how you write the expansion, right? So usually, we were in the question were asking you to expand up to a certain term. So now this is the first term, second term, third term, fourth term, fifth term, sixth term, right? So somehow they were asking you to expand. For example, if this question they said expand up to the term, alright? Expand up to the term with x cubed. Means they only want to up to the term x cubed. Means that x power 4, you are not interested. Because if you write, if they never asking you to stop, it won't stop. Alright, so I just now I write this is just for you to understand the pattern. So now you know that up to x to the power of 3 means you have to stop here. You have to stop here, then you put a dotted here to show that there is continue. Alright, you have to continue. So but for this, you just expand up to the third term. Alright, if they said expand up to the term with x power of 3, yeah, this is the term, means you have fourth term, right? If they said expand up to the term with x squared, so this one you're going to erase away. So if they said expand for the first 3 terms, this will be the first 3 terms. You have to follow the question, alright? So now this is the case. So how to evaluate this? This is something that students think very ridiculous when they want to using calculator. It's very tired. Okay, let's see. I'm going to teach you how to using calculator for these cases. Right? Of course, this will be easy. The first one, 1. Right? 1 minus with 3 over 2. Right? 3 over 2x. Right? Okay, now for this case, now right? And this one, negative 3 to the power of 2. You have to be careful when you using calculator, right? So you look at using this calculator, you using the fraction, key in the fraction, then you have everything you put bracket 1 over 2, right? 1 over 2 bracket, then you have 1 over 2 minus 1, right? Minus 1. Okay, key in exactly the same as this. But don't forget the negative 3 to the power of 2, right? Negative 3 power of 2 is 9, right? So you have, okay, or you just key in as negative 3 to the power of 2, right? For the denominator, you have 2 factorial, shift, can you see there's a button here, factorial, factorial. So you see exactly the same, right? Exactly the same. So then you pressing equal, then you have negative 9 over 8. So means the third term will be negative 9 over 8x to the power of 2. Okay, let's go for the third term. The third term, you have to key in so many things, right? So I teach you the short way. Okay, you don't key in this. Okay, you don't key in again. So you're pressing the AC button, right? Then you're pressing any arrow here. So you will get back what you do just now. So you just add another bracket in between this, right? You can add bracket here. Now you have 1 over 2. 1 over 2. Sorry. Okay, you have to add bracket because I'm going to key in inside the bracket. So 1 over 2, right? 1 over 2. Now you have minus 2, right? 1 over 2 minus 2. So for the below, you convert become 3 factorial, shift factorial. Alright, this is easier. So 1 over 2 minus 1, and checking. 1 over 2 minus 2. And negative 3, don't forget, the negative 3 now is no longer power of 2, right? It's no longer power of 2, it's power of 3, right? Negative 3 to the power of 3. So you just delete the 2 and you key in the 3, right? So everything now is okay, so you're pressing the button equal. You have negative 27, negative 27 over 16, x to the power of 3. So the plus ... you have to put back because this series is not terminate. Alright, they just ask you to expand up to the term with x cubed, but it's actually non-terminating. So your answer should be this. Alright, this is your expansion for this series, right? But initially I tell you that this expansion is not valid, you know. It's not valid for all the time. If you have 1 minus 3x to the power of 2, you have 2 bracket, right? If power of 3, you have 3 bracket. This one you can see, right? You can see, you know that yes, this is true. But this is actually not true for all the case, right? We are actually approaching. If you study further for your about the sequence in calculus, you will know that this is one of the power series or Taylor series, something like that. So 1 minus 3x square root. So if you want to use this formula, you have a condition where the term, if here is already 1, you take the b term, you have to less than 1, right? So by now you have to know that this is the range of validity, interval of validity. Or we said interval of validity. Means that this expansion is valid if and only if the value, the magnitude of negative 3x is less than 1, right? So you can modulus of negative 3, you can take out the modulus of negative 3 and modulus of x less than 1. Modulus of negative 3 is 3. Modulus of x less than 1. So modulus of x is less than 1 over 3. So in chapter 2, you know that this definition, right? Less than a. So you can write in between 1 over 3 and negative 1 over 3. So this was the condition. So if this expansion is valid, the value of x must be between these two values. Alright, means that outside the range here, this expansion is no longer valid. So I hope you understand about the expansion. First, I tell you how to look at the pattern to do the expansion for this problem. Second, you have to know the range of validity, how to identify. The range of validity is always you take the b term, the magnitude of the modulus of the b term less than 1. Alright, so if you not very understand, I will give you 2 more examples. Okay, let's look at the next video.